Welcome to Astro Odyssey. Explore the universe. The story of our solar system begins not with the familiar stability we know today, but in a desolate, swirling graveyard of long-dead stars. Over 4.5 billion years ago, there were no blue oceans or green continents. There was only a colossal cloud of interstellar gas and dust drifting through the vacuum of space. Deep within this nebula, gravity began to pull at the scattered remains of the past, drawing matter inward toward a central point of no return. It was a time of immense silence before a catastrophic birth. As the pressures at the center of this cloud mounted to an unbearable degree, in an instant of cosmic history, the heart of this nebula ignited and our sun was born. This spark of fusion transformed the darkness into a radiant theater of heat and light. But the sun's arrival was not a peaceful event. As the young star claimed its throne, it unleashed a fierce solar wind that began to clear the neighborhood, pushing lighter gases toward the outer reaches. However, the sun was not the only power rising from the wreckage. In the chaotic ring of leftover debris, something massive was beginning to stir. Fueled by the very materials the sun had, discarded among the millions of rocky fragments and ice crystals orbiting the newborn star, one object stood out by virtue of its sheer ferocity. This was the protoplanet that would become Jupiter, and it was growing faster and more aggressively than any of its siblings. While the inner planets struggled to gather enough solid matter to form small, rocky shells, Jupiter moved with a hunger that bordered on the predatory. It quickly reached a critical massa tipping point where its gravitational pull became so strong that it could do what no other planet could. It began to swallow the gas itself. This period of rapid growth turned Jupiter into a vacuum cleaner of the cosmos. It didn't just collect rocks. It gorged on the vast reservoirs of hydrogen and helium that permeated the early solar system. As it grew, its gravity became a dominant force, warping the paths of everything in its vicinity. It was a violent, turbulent era where the young king asserted its dominance, carving a massive path through the protoplanetary disk and ensuring that no other planet would ever come close to its scale. As Jupiter swelled into a gas giant, it effectively split the solar system in two. By anchoring itself in the mid-ground of the system, it acted as a gravitational barrier, preventing the icy materials of the outer reaches from drifting too close to the sun. This was the moment the king truly took his seat. His presence dictated the orbits of every other object in the vicinity, determining which fragments of rock would be allowed to form planets and which would be cast out into the cold, dark void of interstellar space. The violence of Jupiter's youth cannot be overstated. Its migration through the early solar system was like a wrecking ball swinging through a construction site. Scientists believe Jupiter may have spiraled inward toward the sun, its massive gravity scattering the building blocks of the inner planets and stunting the growth of Mars. Had it continued its inward trek, it might have swallowed the Earth before our world even had a chance to breathe. But a gravitational dance with its brother Saturn pulled the king back, stabilizing the system in the nick of time. Today, Jupiter stands as a magnificent, swirling monument to those ancient, chaotic years. It is a world of extreme contradictions, a beautiful tapestry of pastel clouds and ammonia, crystals that masks a core of crushing pressure and metallic hydrogen. Its great red spot, a storm larger than the Earth itself, has raged for centuries, a lingering reminder of the primordial energy that birthed the planet. It is not just a planet. It is a failed star, a celestial body that contains more than twice the mass of all the other planets in our solar system combined. beyond its own physical majesty. Jupiter serves as the ultimate protector of the inner solar system. Its massive gravity acts as a cosmic shield, attracting or deflecting deadly comets and asteroids that might otherwise collide with Earth. We owe our existence, in part, to this silent sentinel. Every time a potential dinosaur killer is flung out into the Kuiper Belt or swallowed by Jupiter's thick atmosphere, the king reaffirms his role as the guardian of the sun's domain. Jupiter's influence also extends to its court of over 90 moons, a miniature solar system in its own right. From the volcanic hellscape of Io to the hidden icy oceans of Europa, these moons are shaped and tortured by Jupiter's immense tidal forces. They are the subjects of the king, held in a tight gravitational embrace that generates heat and energy far from the sun's warmth. In these moons, we see the true extent of Jupiter's power, the ability to create environments where life might actually have a chance to ignite in the dark. To understand Jupiter is to understand the biography of our own origins. We are the beneficiaries of its hunger and the survivors of its violence. From a cold graveyard of stars to the reigning monarch of the gas giants. The story of Jupiter is the story of how chaos became order. It is the biography of the king, the most massive, most violent, and most essential character in the epic poem of our solar system. The birth of Jupiter was not a slow, graceful transition, but a sequence of high-stakes collisions occurring in the deep freeze of the outer solar system. Beyond the frost line, the invisible boundary where the sun's warmth fades enough for water and volatiles to freeze into solid grains, the building blocks of planets were fundamentally different. While the inner solar system was a desert of dried dust, the region Jupiter occupied was a lush reservoir of ice and rock. This abundance of raw material provided the perfect environment for a gravitational game of marbles, where the stakes were nothing less than planetary supremacy in these frigid outskirts. Jupiter didn't start as a majestic giant. It began as a celestial bully. Giant shards of ice and boulders the size of mountain ranges were caught in a violent dance, drawn together by a relentless gravitational pull. These objects didn't just meet. They collided with such kinetic energy that they fused together under extreme heat and pressure. This was a brutal era of accretion, where the largest fragments grew by consuming their smaller neighbors, systematically clearing their orbital paths and asserting a localized dominance that would soon reshape the entire solar system. Within just a few million years, a mere blink of an eye in the vast expanse of cosmic timeless, process of violent accumulation reached a terrifying milestone. Through constant bombardment and the merging of countless planetesimals, Jupiter had constructed a solid core 10 times the mass of the Earth. This core was a dense, pressurized heart of rock and ice, sitting in the middle of a swirling vortex of gas. At this specific mass, Jupiter reached a physical tipping point known as runaway gas accretion. A moment where the planet's destiny shifted from a large, rocky world to a gas-swallowing behemoth. Once this threshold was crossed, the rules of the game changed. Jupiter's gravity became so immense that it no longer relied on the slow process of catching rocks. It began to drink the very atmosphere of the solar system. The vast reservoirs of hydrogen and helium gas that remained from the sun's birth were pulled inward by an inescapable force. Trillions of tons of gas began to rain down onto the core every second, causing the planet to balloon in size at an exponential rate. It was no longer a resident of the solar system. It was becoming its master, as Jupiter gorged on the nebula's gas. It became a monster of physics, growing so fast that it began to starve the other emerging planets. By vacuuming up the lion's share of the available hydrogen and helium, it ensured that no other planet could ever challenge its scale. This rapid growth created a massive gravitational wake, ripples of energy that distorted the orbits of everything nearby. The gas giant was now so heavy that its presence began to physically warp the structure of the protoplanetary disk, carving a wide, empty lane in the dust that surrounded the young sun. This growth spurt was not just an internal transformation. It was a declaration of war on the surrounding debris. The sheer volume of material Jupiter inhaled created a vacuum that destabilized the orbits of nearby asteroids and comets, flinging them inward, toward the sun, or outward into the dark. The bully had grown into a titan, and its gravitational reach was now measured in hundreds of millions of miles. It was during this phase that Jupiter's distinctive stripes and zones likely began to form. As the massive influx of gas swirled into complex, high-velocity, atmospheric currents underneath the thickening layers of gas, the pressure became so intense that the laws of chemistry began to bend. Hydrogen, normally a gas, was crushed into a liquid, and eventually into a bizarre state known as metallic hydrogen. This transition created a massive planetary dynamo, generating a magnetic field of such staggering proportions that it could be felt all the way at the edges of the solar system. Jupiter was no longer just a collection of matter. It was a powerhouse of electromagnetic energy, radiating more heat into space than it received from the distant sun. As the gas supply eventually began to dwindle, swept away by the sun's maturing solar winds, Jupiter's feeding frenzy finally slowed. However, the damage in the creation was already done. The planet had reached a final mass that dwarfed everything else in orbit, sitting at the center of a complex web of gravitational influence. It had become the king, an anchor that provided a sense of order to the outer system, while remaining a source of chaos for anything that dared to cross its path. This transformation from a rocky bully to a gaseous monster serves as the foundational chapter of our solar system's history. Without Jupiter's hungry phase, the architecture of our cosmic home would be unrecognizable. It acted as a gatekeeper, deciding which materials would be allowed to reach the inner planets, and which would be trapped within its own massive belly. The Earth we walk upon today was shaped in part by what Jupiter chose not to eat during those first few million years of gluttony. Ultimately, the biography of Jupiter is a story of power and timing. By being the first to reach that critical tipping point, it claimed the best of the solar system's resources for itself. It remains today as a beautiful yet terrifying reminder of that ancient era swirling. Colorful giant that was born from the cold, grew through violence, and eventually settled into its role as the undisputed heavyweight champion of the stars. While Jupiter had claimed his throne as the heavyweight of the solar system, he was far from a settled monarch. New scientific theories, most notably the Grand Tack, paint a picture of a restless, wandering giant. Shortly after its explosive growth, Jupiter began a terrifying death march toward the center of the solar system. Driven by the thick, viscous gas still swirling in the protoplanetary disk, the king began to spiral inward, drawn by the sun's immense gravity. This wasn't a peaceful journey. It was a cosmic invasion that threatened to undo everything the young solar system had built. As Jupiter migrated inward, it acted as a gravitational wrecking ball of unprecedented scale. It plowed into the warm inner regions of the solar system, the very habitable zone where rocky planets were desperately trying to assemble. This was a realm of chaos and destruction. Jupiter's massive presence didn't just nudge these smaller objects. It dominated them, warping their orbits and turning a construction site into a demolition zone. The king was moving into a territory that was never meant for a giant, and the consequences for the inner system were catastrophic. Before the Earth we know today ever existed, there was likely a first generation of planets. These were super-Earths, rocky worlds much larger and more massive than our own, which are common in other star systems across the galaxy. As Jupiter swept through their neighborhood, its gravity acted like a giant scythe. It sent these protoplanets into wild, eccentric orbits, causing them to collide with one another at high velocities. Many were ground into dust, while others were pushed into a terminal spiral, eventually being consumed by the solar fires of the young sun. In this version of history, Jupiter was the villain of the inner solar system, an accidental destroyer that left a trail of planetary wreckage in its wake. Had this inward march continued, Jupiter would have eventually settled into an orbit close to the sun, becoming what astronomers call a hot Jupiter. In such a scenario, the small, rocky worlds like Earth would never have had the chance to form, and the inner solar system would have remained a barren, scorched wasteland dominated by a lone, bloated giant. However, the story of our solar system is one of narrow escapes. The reason we are here today to tell this story is thanks to a cosmic rescue mission led by Jupiter's younger brother Saturn. As Saturn grew in the outer reaches, its own gravitational pull began to influence the king. Like two celestial dancers locked in a tug-of-war, the two giants entered a mean motion resonance. For every 3 times Jupiter orbited the sun, Saturn orbited twice. This specific mathematical harmony created a powerful gravitational anchor that halted Jupiter's inward progress. This interaction resulted in the tack, a term borrowed from sailing where a boat changes direction against the wind. The combined gravity of Jupiter and Saturn cleared a massive gap in the solar nebula, and the resulting change in gas pressure acted like a giant slingshot. Instead of falling into the sun, Jupiter was pulled back, reversing its course and retreating into the outer dark. This retreat was the most pivotal moment in the history of our world. It was the moment the wrecking ball was finally reined in, when Jupiter finally settled into its current stable orbit. It left behind a solar system that had been fundamentally altered. The inner regions had been cleared of most of their material, leaving behind only a fraction of the debris that had once been there. This explains a long-standing mystery in astronomy: why our inner planets are so small compared to the giants of other solar systems. We are essentially the crumbs left behind after the king's feast, the survivors of a much larger planetary family that was lost to time. From these remaining fragments of rock and metal, the 4 terrestrial worlds Mercury, Venus, Earth, and Mars slowly began to coalesce. Because Jupiter had swept away the super-Earth materials, these worlds were destined to be small, rocky, and fragile. The Earth was born from the wreckage of a cosmic war, a tiny oasis of stability in a system that had been nearly destroyed by its own monarch. Jupiter's Grand Tack defined the very architecture of our home, limiting the size of our world, but also providing the stability needed for it to eventually thrive. This theory changes our perspective on Jupiter from a simple protector to a complex, accidental creator. We owe our existence to its violence as much as its protection. If Jupiter hadn't cleared the inner system, Earth might have been a massive, gas-shrouded super-Earth, where life as we know it could never have evolved. By destroying the first generation of planets and then retreating, Jupiter accidentally created the perfect conditions for a small, watery world like ours to take root. Today, as we look up at the bright, steady light of Jupiter in the night sky, we are looking at the architect of our destiny. The king remains in the outer dark, his restless days of migration long over, serving as a reminder of the narrow margins by which our world survived. The story of the Grand Tack is the story of a rescue mission that happened billions of years ago, ensuring that the small, fragile worlds of the inner solar system could one day look back and wonder how they came to be. Falling into Jupiter is not a crash landing, but an endless, terrifying transition into a realm where the concept of ground ceases to exist. On Earth, we are used to the clear distinction between air, water, and soil, but the king offers no such comfort. As you pass through the pastel ammonia clouds of the upper atmosphere, the sky doesn't just darken, it thickens. You would find yourself sinking through a vertical ocean of gas that gradually becomes as dense as liquid, with no shoreline in sight. This is a world where the atmosphere is the destination, and the descent is a one-way trip into the heart of a physical nightmare as you sink thousands of miles beneath the visible cloud decks. The sheer scale of Jupiter's mass begins to exert its will upon you. On the surface of Earth, the air exerts about 14.7 pounds of pressure per square inch, a weight we barely notice. On Jupiter, that figure undergoes a monstrous transformation. The weight of the miles of atmosphere above you becomes so immense that it is equivalent to having 160,000 cars stacked on every single square inch of your body. In this crushing abyss, the temperature soars to levels hotter than the surface of the sun, and the very molecules of your being would be flattened into a state of matter that defies everyday logic. Under this localized apocalypse of pressure and heat, the fundamental building blocks of the universe begin to behave in impossible ways. The hydrogen that makes up the bulk of the planet's mass reaches a critical state where it can no longer exist as a gas or even a standard liquid. Instead, it undergoes a phase transition into liquid metallic hydrogen. In this alien state, electrons are squeezed off their parent atoms and allowed to flow freely. This isn't a metal you could forge into a sword. It is a shimmering, glowing sea of fluid that acts as both a liquid and a superconductor, representing a state of matter found nowhere else in our solar system. This glowing sea of metallic hydrogen is the true engine room of the Jovian system, because this liquid metal conducts electricity like a massive, planet-sized wire. Its constant churning and spinning, driven by Jupiter's rapid 10-hour rotation, generates gargantuan electrical current. This process, known as the planetary dynamo, creates a magnetic field of staggering proportions. It is 20,000 times stronger than the magnetic field of the Earth, a force so powerful that it accelerates charged particles to near-light speeds, creating lethal radiation belts that sizzle the space around the planet. The result of this internal electricity is the Jovian shield. It's a magnetic bubble or magnetosphere that represents the largest single structure in our solar system. If this magnetic field were visible from Earth, it would appear twice as large as the full moon in our night sky. This shield is so expansive that its tail stretches out hundreds of millions of miles, touching the orbit of Saturn. It carves out a massive sanctuary in the solar wind, acting as a celestial fortress that protects Jupiter's many moons from the sun's radiation, while simultaneously acting as a trap for any cosmic debris that wanders too close. For decades, scientists imagined a solid, rocky core at the very center of the Kinga, definitive seed around which the gas gathered. However, recent data from the Juno mission has revealed a much stranger reality. a fuzzy or dilute core. Instead of a hard sphere of rock and iron, the center of Jupiter is a sprawling, chaotic soup of dissolved elements. The heavy materials that originally formed the planet's heart are no longer distinct. They have been partially dissolved and stirred into the metallic hydrogen. This lack of a clear boundary is a haunting relic of the planet's violent birth, suggesting an ancient impact so large it shattered the king's heart. The existence of this fuzzy core tells a story of a primordial catastrophe. Astronomers theorize that early in its life, Jupiter may have been struck head-on by another protoplanet 10 times the mass of Earth. This great impact would have pierced through the gas layers and smashed directly into the core, mixing the solid rock with the liquid gas. What we see today is the scarred remains of that event core that is still trying to settle after billions of years. It serves as a reminder that even the king was once vulnerable to the chaotic violence of the early solar system. The energy that leaks out from this crushing interior fuels the most famous features of the Jovian face. The heat rising from the metallic hydrogen sea creates massive convection currents, which are then sheared into horizontal bands by the planet's extreme rotation. These are the stripes we see through telescopes, jet streams of ammonia and sulfur that move at hundreds of miles per hour. Within these bands, storms like the Great Red Spot are fed by the internal heat of the core, acting like atmospheric engines that have been running for centuries without ever running out of fuel, because Jupiter contains so much mass and generates so much internal energy. It acts as the gravitational and magnetic anchor for the entire solar system. Its influence is so heavy that the center of gravity between the Sun and Jupiter actually lies just outside the surface of the Sun. This means the king doesn't just orbit the Sun. The two of them dance around a shared point in space. To fall into Jupiter is to realize that the planet is not just a ball of gas, but a powerful, active participant in the physics of the galaxy, a world that generates its own rules and its own weather. Ultimately, the biography of Jupiter is the story of an object that bridges the gap between a planet and a star. It possesses the mass to dominate, the pressure to transform matter, and the magnetic reach to touch the stars. It is a masterpiece of physics, born from the debris of a graveyard and shaped by a hunger that nearly destroyed our own world. We look at its swirling clouds and see beauty, but beneath those colors lies a terrifying truth. The king is a silent, the glowing monster of liquid metal and crushed atoms, standing watch over the small, rocky worlds that exist only because he allowed them to be. If Jupiter is the undisputed king of the solar system, then its 95 moons are his vast and varied court. Together, they form a mini-solar system so massive and complex that it operates under its own distinct set of physical laws. Within this orbital kingdom, the gravitational influence of the king is the ultimate authority, dictating everything from the volcanic eruptions on the inner moons to the hidden tides of frozen oceans in the outer reaches. This collection of satellites isn't just a random assortment of space rocks. It is a finely tuned celestial machine, where each member plays a specific role in the gravitational harmony of the Jovian domain. Among these dozens of satellites, for worlds stand above the rest, the Galilean moons, Io, Europa, Ganymede, and Callisto. These are not merely small rocks, but full-fledged worlds, some larger than the planet Mercury. They were first glimpsed by Galileo Galilei through a primitive telescope in 1610, a moment that shattered the foundations of human understanding. By observing these 4 bright points of light dancing around the giant planet, Galileo provided the first visual evidence that Earth was not the center of all motion in the universe. It was a discovery that signaled the end of the geocentric era and the beginning of modern astronomy. Closest to the king lies Io, a world that is arguably the most tortured place in the solar system. Io is caught in a relentless gravitational tug-of-war between Jupiter's immense mass and the outer Galilean moons. This constant stretching and squeezing, known as tidal heating, creates so much internal friction that the moon's interior is molten. As a result, Io is a volcanic powerhouse, with hundreds of active vents spewing plumes of sulfur hundreds of miles into space. It is a world of constant renewal, where the surface is paved with fresh lava, making it look like a vibrant, yellow-orange pizza floating in the void. Moving further out, we encounter Europa, a smooth, icy sphere that hides one of the greatest secrets in the cosmos. While its surface is a frozen crust of crisscrossing ridges and cracks. Scientists are almost certain that a deep, salty ocean of liquid water lies beneath. This hidden sea contains more than twice as much water as all of Earth's oceans combined. Warmed by the same tidal forces that plague Io, Europa's dark depths represent perhaps the most promising place in our solar system to search for life. Beyond Earth, a watery sanctuary protected by a miles-thick shield of ice, the third of the great provinces is Ganymede, a moon that defies the traditional definition of a satellite. Ganymede is the largest moon in the solar system, so massive that it would be considered a planet if it orbited the sun directly. It is unique among moons for possessing its own internally generated magnetic field, shield that carves out a tiny territory within Jupiter's much larger magnetosphere. With its own aurorae and layers of ice and rock, Ganymede is a complex, differentiated world that serves as a testament to the sheer scale of the Jovian court. Finally, there is Callisto, the outermost of the Galilean Four, and the most heavily cratered object in the solar system. Unlike its active siblings, Callisto is a geologically dead world. A frozen time capsule that has remained largely unchanged for 4 billion years. Its surface is a battered record of every impact it has ever endured, looking like a dark, crystalline ball of pockmarked ice. Yet even this silent world hides mysteries. Some evidence suggests that deep beneath its ancient, scarred crust, a slow-moving, briny ocean may still exist, kept liquid by the faint remnants of Jupiter's fading tidal grip. The magic of this court lies in the Laplace resonance, a mathematical perfection in their orbits. For every one orbit Ganymede makes, Europa makes exactly 2, and Io makes exactly 4. This synchronization ensures that the moons periodically line up, exerting a rhythmic gravitational pull on one another. This resonance is what keeps their interiors warm and their oceans liquid, so far from the sun's heat. Without this precise orbital dance, the Galilean moons would be nothing more than frozen, lifeless husks. Instead, they are vibrant provinces fueled by the king's gravity. Beyond the 4 giants lies a diverse assembly of smaller, irregular moons. These are the king's outriders, smaller asteroids captured by Jupiter's gravity over eons. They orbit in distant, often chaotic paths, some even moving backward, retrograde, compared to the inner court. These moons serve as a defensive perimeter, graveyard of captured space debris that tells the story of Jupiter's long history as a cosmic vacuum cleaner. They are the remnants of a time when the solar system was a much more crowded and dangerous neighborhood. To understand Jupiter, one must look closer at these provinces, for each one is a world of extremes that reflects a different aspect of the king's power. From the fire of Io to the ice of Europa, the Galilean moons represent the full spectrum of planetary possibility. They show us that gravity is not just a force that holds things down, but a source of energy that can create heat, melt rock, potentially sustain life in the coldest reaches of space. The court of Jupiter is a laboratory of physics where the rules of the universe are pushed to their limits. In the end, the Jovian system stands as a reminder that Earth is but one small part of a much larger, more diverse story. When Galileo looked through his telescope and saw those 4 moons, he didn't just find new worlds, he found a new perspective. He saw a miniature solar system that mirrored the grand architecture of the universe itself. Jupiter and its court remind us that even in the dark, cold vacuum of the outer solar system, there is motion, there is energy. And there is the potential for something extraordinary to emerge from the chaos. Closest to the king lies Io, a world that exists in a state of perpetual agony and transformation. It is a moon of fire and brimstone, holding the title of the most geologically active object in our entire solar system. Unlike the cratered, silent moons we see elsewhere, Io's surface is a garish, multicolored landscape of yellows, greens, and reds, a chemical palette created by constant volcanic outgassing. It is a place where the calm of space is replaced by the roar of tectonic upheaval, serving as the innermost boundary of the king's immediate influence. The violence on Io is not fueled by the sun, but by a phenomenon known as tidal heating. Io is the victim of a cosmic tug-of-war. It's trapped between the massive gravitational well of Jupiter and the smaller but persistent poles of its sister moons, Europa and Ganymede. Because these moons are locked in an orbital resonance, they periodically align, creating a rhythmic, gravitational heartbeat. This force doesn't just pull on Io's surface. It reaches deep into its core, stretching and squeezing the moon's solid rock like a piece of putty. This constant mechanical kneading generates a staggering amount of internal friction. Just as a paperclip grows warm if you bend it back and forth rapidly, Io's entire interior is liquefied by the heat generated from this gravitational flexing. The energy released is so intense that the moon's surface actually bulges up and down by as much as 300 feet, 100 meters during its orbit. This is not a world of stability. It is a world where the ground beneath your feet is as fluid and temperamental as the sea. In this hellscape, there is no water. Every drop of moisture was baked away eons ago by the intense radiation and heat. In its place stands the Forbidden Forge, a realm where liquid rock and sulfur are the only fluids. The moon is home to over 400 active volcanoes, some of which blast plumes of gas and dust 300 miles into the vacuum of space. These eruptions are so powerful that they can be seen from Earth-based telescopes, appearing as bright, glowing hotspots against the dark backdrop of the Jovian system because of this relentless volcanic activity. Io is a world without a past. It resurfaces itself so frequently that any impact craters from asteroids are quickly filled and paved over by fresh flows of molten silicate and sulfur. It possesses the youngest surface in the solar system, a featureless landscape of ever-changing lava lakes and volcanic calderas. To look at Io is to look at a moon that is literally turning itself inside out, discarding its old skin to make room for the fires rising from its heart, the heat of the forbidden. Forge creates a unique relationship between the moon and its king. As Io erupts, it strips away about a ton of material every second, creating a giant donut of charged particles around Jupiter, known as the Io plasma torus. This material is swept up by Jupiter's rotating magnetic field, creating a massive electrical circuit. This connection generates a staggering 3 million amperes of current between the moon and the planet, igniting permanent aurorae in Jupiter's upper atmosphere. Standing on the surface of Io would be a nightmare of physics. The sky would be dominated by the looming mass of Jupiter, filling nearly 40% of the horizon. The ground would vibrate with the constant thrum of nearby eruptions. And the air, if you could call it, that would be a toxic haze of sulfur dioxide. It is a world that defies the icy expectations of the outer solar system, proving that gravity alone can be a more powerful furnace than the light of a distant star. The volcanoes of Io, such as the massive Loki Patera, are larger than entire terrestrial mountain ranges. These lava lakes are so vast that they create their own weather patterns, with lava waves that ripple across their surfaces. The sheer scale of the geological energy is almost impossible to comprehend. Io radiates more heat than it should be able to hold, a glowing testament to the power of the orbital dance it shares with its siblings. Io serves as a stark warning of what happens when a moon gets too close to its king. It is the extreme example of tidal forces. Taken to their logical conclusion, a world where the crust is merely a thin lid on a boiling cauldron. It is the most vivid illustration of the mini-solar system theory, showing that Jupiter doesn't just hold its moons in place. It physically shapes them, heats them, and consumes them through the sheer invisible weight of its presence. Ultimately, Io is the gateway to the Jovian mysteries. It represents the fire in the story of fire and ice that defines the Galilean court. It is a world of magnificent, terrifying beauty, a celestial forge that never cools, and a reminder that in the shadow of the king, the very rocks can be made to scream. As we move further out toward the icy shells of Europa, the fires of Io provide the essential energy that keeps the entire system alive and moving. Next in line is Europa, a world that stands in hauntingly beautiful contrast to its fiery sibling, Io. If Io is a chaotic hell of molten rock, Europa is a silent, frozen cathedral. From a distance, it appears as a pale, shimmering pearl against the darkness of the outer solar system. Its surface is a brilliant shell of water ice, one of the smoothest in the galaxy, lacking the jagged mountains or deep craters that scar most other moons. This smoothness is a testament to its youth. Like a healing wound, the ice is constantly shifting and renewing itself, erasing the history of cosmic impacts. The most striking features of this frozen landscape are the linea, mysterious, dark, reddish-brown lines that crisscross the moon like a global web of veins. These are not mere surface markings, but massive fractures in the ice crust, some stretching for thousands of miles. Scientists believe these lines are caused by the moon's ice shell being pulled apart by Jupiter's gravity. As the ice cracks, warmer slush or liquid water from below wells up to fill the gaps, freezing into dark ridges that create a complex, geometric tapestry across the moon's face. However, the true story of Europa does not exist on its frigid surface, but 10 miles beneath the ice. Hidden from the sun's lethal radiation and the vacuum of space is a global saltwater ocean that encompasses the entire moon. This subsurface sea is estimated to be up to 60 miles deep, making it so vast that it contains more than twice the amount of water found in all of Earth's oceans combined. This makes Europa a water world in the truest sense, celestial reservoir of the most fundamental ingredient for life. This hidden ocean is the holy grail of space exploration. For decades, scientists assumed the outer solar system was too cold for liquid water, but Europa defies these expectations. The moon is heated by the same relentless tidal forces that plague Io. As Jupiter's gravity kneads Europa's interior, it generates internal heat through friction. This thermal energy prevents the deep ocean from freezing solid, maintaining a liquid environment that has likely persisted for billions of years, protected by a miles-thick shield of protective ice. Deep within these dark, pressurized depths, the conditions may be eerily similar to the floor of our own oceans. Scientists theorize that Europa's seafloor is in direct contact with a rocky mantle, allowing for the existence of hydrothermal vents. On Earth, these black smokers are chemical cradles where heat and minerals from the interior meet the cold ocean water, creating a nutrient-rich soup. Many biologists believe these vents were the very sites where life on Earth began, operating entirely independent of sunlight in the cold darkness of the Jovian system. Europa represents our best hope for finding a second Genesis. If life exists in its hidden ocean, it would prove that biology is not a fluke unique to Earth, but a common consequence of physics and chemistry. The discovery of even the simplest microbial life in Europa's depths would fundamentally change our place in the universe, suggesting that anywhere there is water, heat, and chemistry, life will find a way to take root. The chemistry of Europa is fueled by a unique interaction between its surface and its interior. While the ocean is dark, the icy surface is bombarded by high-energy particles from Jupiter's radiation belts. This process breaks apart water molecules to release oxygen. Scientists suspect that as the ice shell churns and recycles itself over millions of years, this oxygen may be carried downward into the liquid ocean. If this is true, the sea below could be rich in the chemical energy needed to support complex multicellular organisms. Exploring this world remains one of humanity's greatest technical challenges. To reach the ocean, a probe would have to survive Jupiter's intense radiation, land on a jagged icy landscape, and then melt or drill through miles of incredibly hard, cold ice. Yet, the reward is worth the risk. Missions like the Europa Clipper are already being designed to fly through the plumes of water vapor that occasionally geyser out from the moon's cracks, allowing us to taste the ocean without even landing. Europa reminds us that the habitable zone of a star is not the only place where life can thrive. Gravity can be just as effective an energy source as starlight. By transforming tidal friction into a life-sustaining heat, Jupiter has created an oasis in the deep freeze of space. Europa stands as a testament to the king's power to foster environments that are hidden from view. Tucked away in the shadows of the gas giants where the laws of biology might be rewritten. As we look toward the future of exploration, Europa remains a beacon of hope and mystery. It is a world that invites us to look beneath the surface, to question our definitions of habitable, and to imagine a dark, watery realm where alien life might be swimming at this very moment. In the grand biography of the king, Europa is the chapter on Potentiala, frozen cathedral. That may very well be a nursery for a second branch of life in our solar system. Beyond the icy plains of Europa lies Ganymede, the undisputed heavyweight champion of the Jovian system and the largest moon in the entire solar system. Ganymede is a titan in its own right, a colossal world that is actually larger than the planet Mercury. If it were orbiting the sun directly, instead of being tethered to Jupiter, it would undoubtedly be classified as a primary planet. Its surface is a scarred and ancient map of the solar system's history, featuring dark, cratered regions that are billions of years old, intersected by lighter, grooved terrain that suggests the moon has experienced its own version of tectonic activity. However, Ganymede's true significance lies not in its size, but in a secret hidden deep within its bowels, a secret that even some full-fledged planets like Mars or Venus do not possess. Ganymede is the only moon in the known universe to generate its own intrinsic magnetic field. This isn't just a faint remnant of magnetism. It is an active, protective shield. While the other moons are completely at the mercy of Jupiter's immense magnetosphere, Ganymede carves out its own tiny territory of influence, standing as a defiant, independent world within the king's domain. This magnetic field is powered by a churning engine at the moon's center. Deep within Ganymede lies a metallic iron core that remains molten even billions of years after its formation. As the moon rotates, the fluid motion of this molten iron creates a planetary dynamo. The same mechanism that generates Earth's magnetic field, this spinning heart creates a magnetic bubble or magnetosphere that deflects Jupiter's lethal radiation. Because of this, Ganymede possesses its own auroral glowing curtains of light that shimmer in its thin atmosphere, dancing to the rhythm of its own internal heartbeat. The internal structure of Ganymede is just as remarkable as its magnetic shield. Scientists describe the moon as having a club sandwich architecture, a complex arrangement of ice and liquid water layers stacked like a deck of cards. Instead of one single ocean, Ganymede may hold multiple layers of salt water separated by different phases of hypersure ice. This layered ocean model suggests that liquid water might be trapped at various depths, potentially creating unique chemical environments, where minerals and salts are squeezed between sheets of crystalline ice. This stacking of layers is a result of the immense pressure found deep within such a massive moon. At certain depths, the pressure is so great that water is forced into exotic forms of ice that are denser than the liquid itself. This creates a vertical labyrinth where a saltwater ocean might be sandwiched between a top layer of standard ice and a bottom layer of ice V or ice 7. This complex stratification makes Ganymede one of the most structurally sophisticated bodies in the solar system. A world where the very definition of an ocean is pushed to its physical limits. The presence of this magnetosphere makes Ganymede the most planet-like of all Jupiter's subjects. It possesses all the hallmarks of a major world, a differentiated interior, a protective magnetic shield, a thin oxygen atmosphere, and a history of geological upheaval. Standing on the surface of Ganymede, you would be shielded from the worst of the Jovian radiation belts. Looking up at a sky where the auroral lights are governed not by the distant sun, but by the very ground beneath your feet, despite its independence, Ganymede remains locked in the Laplace resonance with Io and Europa. This gravitational bond ensures that Ganymede's orbit remains stable and its interior stays warm enough to keep its dynamo spinning. It is the anchor of the Galilean trio, providing the gravitational weight that helps maintain the heartbeat of the inner court. It is a world that has found a way to be part of the king's court while maintaining its own sovereign identity. Through its magnetic power, Ganymede's surface also tells of story of ice tectonics, the groove terrain, which looks like giant rake marks across the surface, indicates that the moon's crust was once pulled apart or shifted by internal forces. This suggests that Ganymede was once much more active than it is today, perhaps during a time when its internal heat was even more intense. These grooves are the scars of a moon that was once expanding and contracting, a giant world that struggled to contain the energy of its own formation. In the biography of the king, Ganymede represents scale and sovereignty. It proves that a moon can be more than just a satellite. It can be a world with its own internal life and its own protective armor. As we study Ganymede, we see a mirror of Earth's own internal processes, albeit in a frozen alien context. It is a reminder that the solar system is full of almost planets, worlds that were just one orbital shift away from being stars in their own right. Ultimately, Ganymede is the silent giant of the Jovian court. It doesn't erupt like Io, And it doesn't hide its ocean as provocatively as Europa. But it's quiet. Magnetic strength makes it perhaps the most stable and enduring of the king's provinces. It is a world of layers, mysteries, and magnetic shields a titan that stands as a bridge between the small rocky worlds of the inner system and the gas giants of the outer dark. Finally, we reach the furthest of the great Galilean provinces, Callisto. While its siblings are locked in a frantic dance of volcanic fire, shifting ice, and magnetic dynamos, Callisto exists in a state of eternal stagnation. It is a ghost of the past, a world that has effectively been frozen in time since the very dawn of the solar system. If the inner moons are the active living members of the court, Callisto is the ancient librarian, preserving a pristine record of every cosmic trauma that has occurred in the king's domain for over 4 billion years. Callisto holds the somber title of the most heavily cratered object in the solar system. There is virtually no square inch of its surface that hasn't been battered by an impact. Because the moon lacks the internal heat of Io or the resurfacing ice of Europa, it has no way to heal its wounds. Every scar on its surface, from tiny pits to massive multi-ring impact basins, remains exactly where it fell eons ago. To look at Callisto is to see the solar system's fossil record, a visual history of the violent bombardment that characterized the early days of our cosmic neighborhood. Of the most spectacular features of this battered world is Valhalla, a massive impact basin surrounded by concentric rings of frozen ridges, stretching nearly 2,400 miles across. This gargantuan scar was created when a massive object slammed into Callisto, momentarily melting the icy crust and sending shockwaves outward. Because Callisto cooled so quickly afterward, the ripples stayed, creating a permanent monument to a collision that would have obliterated a smaller world. Physically, Callisto is a world of mixed identity. It is nearly the size of Mercury, composed of approximately equal parts rock and ice. Unlike Ganymede or Jupiter itself, Callisto is undifferentiated, meaning its interior is not neatly layered. Instead of a distinct core and mantle, it is a jumbled mixture of rock and ice that never fully melted or settled. This lack of internal structure is proof of its dead status. It never possessed enough internal energy to become a complex layered world, making it a primitive relic of the original material that formed the Jovian system. Yet, even this dead world may hide a secret. Despite its lack of tidal heating, some magnetometer data suggests that Callisto might harbor a salty, liquid ocean deep beneath its battered crust. If it exists, this ocean would be incredibly slow-moving and cold, insulated by a massive thickness of rock and ice. This suggests that the king's gravitational influence is so profound that it can coax liquid water, even out of its most distant and neglected subjects. Though Callisto's sea would likely be a dark, stagnant realm compared to the vibrant depths of Europa, the true value of Callisto for the future of humanity lies in its geography. Because it sits at the outer edge of the Galilean court, it is located far from Jupiter's lethal radiation belts. While a human standing on Io or Europa would receive a fatal dose of radiation in minutes or hours, Callisto is a relatively safe harbor. The radiation levels on its surface are low enough that humans could potentially survive. Therefore, extended periods with minimal shielding, making it the most logical site for a future base of operations. Callisto is often cited as the ultimate outpost on the edge of the empire. It provides a stable, geologically quiet platform from which we could explore the rest of the Jovian system. Future astronauts could live in the shadows of its ancient craters, using the moon's ice as a source of water and fuel, while launching missions to the more dangerous inner moons. It would serve as the port of entry to the king's domain, a silent, steady anchor in a system defined by chaos. The visual experience of standing on Callisto would be one of haunting solitude. In the sky, Jupiter would appear smaller than it does from the inner moons, still a massive banded presence looming over the horizon. The landscape would be a jagged forest of ice spires, eroded remnants of crater rims that have been slowly sculpted by the vacuum of space. Over billions of years, it would be a world of deep blacks and brilliant whites, a monochrome desert of ancient ice, where the only sound is the static of your own radio. In the biography of the king, Callisto represents endurance. It is the silent witness to the violence the king has endured and the chaos he has survived. While the other moons represent the dynamic potential of the future, Callisto represents the cold reality of the past. It is the graveyard of the solar system's youth, the place where the history of our origins is written in stone and ice, waiting for someone to land and read the stories carved into its battered face. As we move from the edge of the court, back toward the king himself, we realize that the story of Jupiter is not complete without Callisto. It provides the context for the king's power. Its craters are the bruises from the asteroids Jupiter has intercepted, and its stability is the result of its distance from the king's intense embrace. Callisto is the final period at the end of the Jovian sentence, quiet, frozen world that marks the boundary between the empire of the king and the endless void of the outer dark. To look at Jupiter through a telescope is to see a serene masterpiece of pastel clouds and marble-like swirls. But what our eyes cannot see is far more terrifying. Beyond the aesthetic beauty of its atmosphere, Jupiter is wrapped in an invisible shroud of electromagnetic fury that dominates the space for millions of miles. This is the Jovian magnetosphere, a colossal, invisible bubble of magnetic force that represents the largest single structure in our solar system. If this field were somehow made to glow in the night sky, it would appear twice the size of the full moon to the naked eye on Earth. Despite Jupiter being hundreds of millions of miles away, this magnetic kingdom is not a peaceful sanctuary. It is a lethal death trap. Driven by the churning liquid metallic hydrogen deep within the king's interior, the field acts like a giant particle accelerator. It traps electrons and ions, mostly sulfur and oxygen, spewed out by the volcanic moon Io, and whips them into a frenzy, accelerating them to near light speeds. These particles become stuck in the magnetic lines of the planet, creating radiation belts of such staggering intensity that they represent the most dangerous environment in the solar system outside of the sun itself. For a human being, his environment is unsurvivable. The radiation belts are so potent that an unprotected astronaut would receive a lethal dose of radiation in a matter of seconds. It is an invisible fire that doesn't just burn the skin, but shreds DNA and destroys cellular structures instantly. Even our most sophisticated robotic explorers, the pinnacle of human engineering, view Jupiter as a suicide mission. Spacecraft like Juno must be armored in massive vaults of lead and titanium, effectively bulletproof vests for electronics just to survive. A few brief passes through the king's territory without being fried. The magnetosphere serves as the king's moat, a terrifying, the invisible barrier that keeps the rest of the universe at bay. It carves out a massive volume of space where the sun's own solar wind is forced to flow around the Jovian system like water around a boulder in a stream. Within this moat, the rules of the solar system are suspended, replaced by the chaotic physics of Jupiter's own making. It is a fortress of energy that protects the king's court of moons, while simultaneously threatening to destroy anything that dares to approach the throne without an invitation. The scale of this moat is difficult to comprehend. The magnetosphere extends toward the sun for nearly 2 million miles, but its tail, pushed by the solar wind, stretches behind the planet for over 400 million miles, reaching all the way to the orbit of Saturn. This means that at certain times of the year, Saturn actually passes through the wake of Jupiter's magnetic influence. The King's reach is so long that it touches other giants, exerting a subtle electromagnetic pressure on the distant provinces of the outer solar system. This magnetic field also creates a spectacular, permanent light show at the planet's poles. As the high-speed particles are funneled down the magnetic lines into the atmosphere, they collide with gases to create colossal aurorae. Unlike Earth's northern lights, which are sporadic and driven by solar activity, Jupiter's aurorae are a constant thrumming roar of energy. They are thousands of times more powerful than our own and glow in wavelengths like ultraviolet and X-ray. Invisible to human eyes, but screaming with power across the electromagnetic spectrum. The moat is also a source of intense radio noise. Jupiter is the loudest radio source in the sky after the sun. The interactions between the magnetosphere, the solar wind, and the moon Io create powerful bursts of radio waves that can be picked up by simple antennas on Earth. It is as if the King is constantly broadcasting a low, guttural warning to the rest of the galaxy, a rhythmic, crackling sound that serves as a reminder of the massive electrical currents flowing through the Jovian heart. This environment presents a unique challenge for the moons that live within it. While the magnetosphere protects the moons from the sun's radiation, it simultaneously subjects them to a sandblasting effect from the trapped particles within the belt. On moons like Europa, these high-energy particles strike the icy surface, breaking apart water molecules and creating a thin atmosphere of oxygen. The King's moat is therefore both a protector and a destroyer, a source of chemical energy that might feed life while threatening to extinguish it with radiation. To study the magnetosphere is to study the limits of planetary physics. It is the ultimate laboratory for understanding how plasma behaves under extreme conditions. Every mission we send to Jupiter is a gamble against these invisible forces. We must dip our instruments into the moat, gather a few precious scraps of data, and retreat as quickly as possible before the electronics succumb to the Jovian flu, the inevitable degradation caused by the constant bombardment of high-energy electrons. Ultimately, the magnetosphere is the true expression of Jupiter's power. It is the invisible crown of the King, a testament to the fact that his influence is not limited to what we can see with our eyes. It is a reminder that in the vacuum of space, the most dangerous things are often the ones that are hidden. The King stands at the center of his electromagnetic fortress, a silent, glowing giant protected by a moat of light and fury, ensuring that his biography remains a story of unrivaled dominance in the dark at the poles of Jupiter. The invisible fury of the magnetosphere manifests as a light show of unparalleled scale and intensity. Unlike Earth's auroras, which are intermittent guests, triggered by the temperamental arrival of solar storms, Jupiter's auroras are a permanent feature of the planet. They do not wait for the sun to stir. They are powered by the King's own relentless 10-hour rotation and the violent geophysics of his court. This is a world where the night never truly falls, as the polar skies are forever illuminated by a shimmering crown of cold, blue fire that never dims. This celestial light show is fueled by a massive, invisible umbilical cord connecting the planet to its volcanic moon, Io. as Io's volcanoes spew sulfur and oxygen into space. These particles are stripped of their electrons and trapped by Jupiter's magnetic field. This creates a colossal electrical circuit, with millions of amps of electricity flowing directly between the moon and the planet's poles. This phenomenon, known as the Io flux tube, acts like a planetary-scale power line, pumping a constant stream of energy into the Jovian atmosphere and leaving a distinct auroral footprint, glowing in the clouds that follows Io's position in the sky. The power output of this system is nothing short of staggering. Jupiter's auroras are hundreds of times more energetic than any northern or southern light seen on Earth, while our auroras are delicate wisps of green and red visible to the naked eye. Jupiter's crown screams across the electromagnetic spectrum, emitting high-energy X-rays and ultraviolet light. The energy released at the poles is so immense that it actually heats the planet's upper atmosphere. Defying the laws of distance that suggest a world so far from the sun should be frozen to its core, this crown of cold fire is a direct result of the King's rapid spin. Because Jupiter rotates so fast, its magnetic field lines are dragged through space like the spokes of a giant wheel, whipping the trapped plasma into a frenzy. This centrifugal force flings the particles toward the poles at incredible velocities. When they finally collide with the hydrogen gas in the atmosphere, they ignite in a brilliant ultraviolet glow. It is a self-sustaining engine of light, a testament to a planet that generates its own weather, its own heat, and its own eternal luminescence. To an observer equipped with ultraviolet vision, the poles of Jupiter would look like a swirling vortex of electric blue and violet. The auroral ovals are not static circles, but complex, evolving structures of spots, streaks, and curtains that pulse with the rhythm of the planet's internal dynamo. They represent the ultimate interface between the solid interior of the King and the vacuum of space, a place where the invisible lines of magnetic force become visible, painting the sky with the energy of a million lightning bolts. The scale of these auroras is so vast that the Earth could easily fit inside one of the glowing polar rings. Within these rings, the atmospheric gases are ionized into a plasma state, creating a localized environment that is more like the corona of a star than the atmosphere of a planet. This is the King's true crown, a symbol of his absolute authority over his domain. It is a sign that Jupiter is not merely a passive object reflecting the sun's light, but a dynamic powerhouse that commands the very atoms around it. Beneath this glowing crown, the planet's deep atmosphere is subjected to a constant bombardment of X-rays. This X-ray aurora is unique to Jupiter among the large planets, suggesting that the acceleration of particles in its magnetosphere is even more violent than previously imagined. Scientists believe these X-rays are triggered by heavy ions from Io crashing into the atmosphere at nearly light speed, a process that releases bursts of energy equivalent to the output of 1,000 nuclear power plants every few minutes. This permanent light show also plays a crucial role in the planet's evolution. By heating the polar regions, the auroras drive complex wind patterns that distribute energy across the entire globe. This may explain why Jupiter's temperature remains relatively uniform from the equator to the poles. Despite the poles receiving almost no sunlight, the King is essentially a self-heating world, using the friction of his own magnetic field to keep his atmosphere churning and his storms alive. For future explorers, the auroras would be both a beacon and a warning. They are the visual signature of the lethal radiation belts that surround the planet. To see the crown is to know that you are standing in the shadow of a giant that can strip the electrons from your very atoms. It is a beautiful, terrifying reminder of the king's power, a lighthouse at the edge of the solar system that has been shining for billions of years and will continue to shine until the sun itself goes dark. Ultimately, the biography of Jupiter concludes with this eternal crown. It is the final piece of the puzzle linking the deep interior, the volcanic moons, and the vast magnetosphere into a single, unified system. Jupiter is the king of the planets not just because of his size, but because of this unrivaled ability to transform motion and magnetism into a masterpiece of light. He stands as a monument to the power of the cosmos, draped in a shroud of fury and wearing a crown of fire, reigning over the dark reaches of the outer solar system. For billions of years, Jupiter has operated as the ultimate paradox of the solar system, playing a dual role as both destroyer and protector. While its early history was defined by the wreckage of the Grand Tack, its maturity has been defined by a silent gravitational vigilance. Its massive mass, containing more than double the material of all other planets combined, creates a gravitational well so deep that it effectively acts as a cosmic vacuum. Cleaner. Anything that wanders into the midriggans of the solar system, be it a stray comet from the Oort cloud or a displaced asteroids likely to be caught in the king's inescapable grip. By pulling in these stray projectiles, Jupiter prevents them from ever reaching the inner solar system, where the smaller, rockier worlds reside. This gravitational interception is the primary reason that Earth is a lush, vibrant oasis rather than a cratered, lifeless wasteland like the moon. Jupiter serves as a massive shield, a celestial linebacker that takes the hit so that the fragile worlds closer to the sun don't have to. Every crater on Jupiter's hidden, fuzzy core, or every fireball that vanishes into its thick clouds, is a potential catastrophe that was diverted away from our home. The statistics of this protection are staggering. Some planetary scientists believe that without Jupiter's presence, the frequency of extinction-level events on Earth would be as much as 1,000 times higher. Instead of an asteroid strike, like the one that ended the reign of the dinosaurs occurring every 100 million years, such impacts could happen every 100,000 years. In such a chaotic environment, complex life would never have had the millions of years of stability required to evolve, crawl out of the oceans, and eventually build civilizations. Image showing Earth's impact history versus a hypothetical Earth without Jupiter. This protective role was famously witnessed by the world in July 1994, when the comet Shoemaker Levy 9 was torn apart and swallowed by Jupiter as the world watched through telescopes. The comet's fragments struck the Jovian atmosphere with the force of millions of nuclear bombs, leaving dark scars in the clouds that were larger than the Earth itself. It was a chilling demonstration of Jupiter's power. It was a death that Earth could never have survived, absorbed effortlessly by the giant. Without that intervention, the history of life in the 1990s might have come to a violent, fiery end. However, the king is a temperamental guardian. Because his gravity is so strong, he doesn't just swallow threats. He sometimes creates them. Jupiter can act as a gravitational slingshot, taking a comet that was heading for the outer dark and hurling it inward toward the sun. This double-edged sword means that, while Jupiter clears most of the debris, he is also responsible for the few dangerous objects that do make it into the inner system. He is the master of the board, deciding which pieces are removed and which are sent into play. We owe our very existence to this gravitational shadow. The Earth resides in a sanctuary of stability created by the king's dominance. By anchoring the asteroid belt and keeping the outer comets at bay, Jupiter has provided the 4 billion years of peace necessary for the blue marble to thrive. We are the beneficiaries of a cosmic bodyguard who has been standing watch since the first sparks of the sun to study. Jupiter is to realize that life on Earth is not just a result of our own planet's merits, but a gift of the giant's protection. This relationship defines the architecture of our survival. If Jupiter were any smaller, the solar system would be a shooting gallery. If he were any larger, he might have become a star himself, making the inner system too hot for liquid water. He is the Goldilocks of gas giants, the perfect size and in the perfect position to foster the conditions for life. The king doesn't just rule the outer dark. He defines the safety of the inner light, acting as the silent shepherd of the terrestrial worlds. As we look to the future, Jupiter continues to be our most important defense. As we track near-Earth objects, we are constantly reminded that the vast majority of potential threats are being managed by the king's gravity. He is the primary reason our orbit remains a low-impact zone. The biography of Jupiter is in many ways a prequel to the biography of Earth. Without the king's hunger, there would be no human history to record, ultimately. The story of the king concludes with this quiet, enduring vigil. From the violent bully of the frost line to the majestic protector of the habitable zone, Jupiter has matured into the most essential character in the solar system. He remains at the center of his court, draped in his electromagnetic shroud and crowned with his blue fire, performing a job he has done for 4.5 billion years. He is the reason we can look at the stars in wonder. Rather than looking at the sky in fear, this is the biography of the king. He is the creator of our world's past, the guardian of its present, and the decider of its future. In the vast, cold graveyard of ancient stars, he rose to claim his throne, and in doing so, he allowed a small, fragile spark of life to ignite on a tiny world called Earth. We live in his shadow. We thrive in his wake, and we exist only by his grace. In July 1994, the world's telescopes were aimed at the outer solar system as the king demonstrated his true, terrifying power in a display of planetary violence never before witnessed by human eyes. The subject was a comet named Shoemaker Levy 9, a traveler from the outer dark that had dared to wander too close to the throne, captured by the king's gravity years earlier. Comet had already been fatally wounded by Jupiter's tidal forces, which had ripped the solid body into 21 distinct fragments. Like a string of celestial pearls, these fragments lined up for a terminal descent, headed straight for the Jovian clouds as the world watched in real time. The fragments began to strike the southern hemisphere of the planet one by one. The kinetic energy involved was almost beyond human comprehension. Because these fragments were traveling at 37 miles per second, 60 kilometers per second, their impact with the atmosphere created a sudden catastrophic release of energy. These weren't just crashes. They were cosmic explosions, each one equivalent to millions of nuclear bombs detonating simultaneously. The king didn't just absorb the comet. He pulverized it, turning solid ice and rock into incandescent plasma in a matter of heartbeats. The visual results of these impacts were staggering. As each fragment plummeted into the thick gases, it created a massive fireball that exploded upward. Plumes of superheated gas and debris rose 2,000 miles over 3,000 kilometers into space. High enough to be seen over the horizon of the planet, these plumes were so hot that they glowed in the infrared spectrum, lighting up the Jovian night like a series of artificial suns. For a brief moment, the king's atmosphere was a battlefield of fire and pressure. showcasing the raw energy that the gas giant holds within its depths. Once the fires subsided, the scars remained. The impacts left giant dark bruises in the colorful cloud. Decks of Jupiter's sooty rings of aerosol debris that were icily visible through even small backyard telescopes on Earth. Some of these dark spots were larger than the entire planet Earth. They lingered for months, drifting with the Jovian winds and slowly fading into the pastel bands of the atmosphere. These weren't just temporary marks. They were a profound physical alteration of the planet's face, a visible reminder of a battle won by the giant. The event served as a chilling whiff. For everyone watching from Earth, it was a realization of the narrow margins of our existence. If Shoemaker Levy 9 had been headed for our world instead of Jupiter, our story would have ended in 1994. The impact of just one of those 21 fragments would have triggered a global winter, collapsed the food chain, and likely caused a mass extinction event. We would have been as helpless as the dinosaurs. Instead, Jupiter acted as a celestial lightning rod, absorbing a blow that would have shattered our fragile world. This event fundamentally changed our understanding of the solar system. It moved the concept of planetary defense from the realm of science fiction into the realm of urgent reality. We saw firsthand that the solar system is still a shooting gallery, and that we are the beneficiaries of a very large, very heavy protector. Jupiter's bottomless clouds of gas acted as a massive cushion, taking the hit and eventually swallowing the evidence. The king didn't just protect us by accident. He protected us by virtue of his sheer mass and inescapable gravitational well. The Shoemaker Levy 9 impact also provided scientists with a rare opportunity to see inside the king. The explosions acted like cosmic probes, dredging up materials from deep within the atmosphere that are normally hidden from our view. By analyzing the light from the impact plumes, astronomers were able to identify water, sulfur, and other chemicals that reside beneath the top cloud layers. The comet's destruction was, in a sense, a sacrifice that provided us with the first chemical map of the Jovian interior, proving that even in destruction, there is a wealth of knowledge to be found. For Jupiter, this was just another day in a 4-billion-year vigil. The planet has likely absorbed thousands of such impacts throughout its history, many of them far larger than Shoemaker Levy 9. Its atmosphere is a graveyard of countless comets and asteroids that might have otherwise plagued the inner planets. The king remains unfazed, his storms continuing to swirl and his auroras continuing to glow, seemingly indifferent to the violence he has just endured. He is a world built for impact, a titan designed to survive the worst the universe can throw at him, standing on the surface of an inner planet. It is easy to feel that we are the masters of our own destiny. But the events of 1994 remind us that we are merely guests in a system ruled by giants. We live in the gravitational shadow of a protector who doesn't even know we exist, yet whose very presence ensures our survival. The dark scars of Shoemaker Levy 9 were a message written in the clouds. This is what I do for you. It was a demonstration of a power so vast that it can turn a world-ending threat into a temporary bruise. Ultimately, the biography of the king is a story of sacrifice and strength. From the early chaos of the Grand Tack to the modern-day defense of the inner system, Jupiter has been the pivotal character in the drama of our solar system. He is the vacuum cleaner, the shield, and the silent guardian. As we look up at the night sky, we should see more than just a bright point of light. We should see the scars of a king who has spent billions of years taking the blows intended for us. ensuring that the fragile spark of life on Earth continues to burn for thousands of years. Jupiter was far more than a point of light in the night sky. It was a celestial enigma that dictated the mythologies of entire civilizations. To the ancients, it was the wandering star, a brilliant, steady beacon that moved with a deliberate, regal pace across the tapestry of the constellations. Because it outshone almost everything else in the heavens and lacked the erratic, blood-red flicker of Mars, it was almost universally associated with the highest tier of the divine. It was a light that didn't just exist in the dark. It commanded it, serving as a silent witness to the rise and fall of empires that looked to it for guidance and omens. To the Romans, this planet was the physical manifestation of Jupiter Optimus Maximus Jupiter, the best and greatest. He was the Sky Father, supreme deity who held the scales of justice and wielded the thunderbolt as a symbol of his absolute authority. His temple atop the Capitoline Hill was the heart of the Roman state, and his movements through the zodiac were believed to mirror the expansion and stability of the empire itself. For a Roman citizen, looking up at that bright light was an act of looking toward the source of law, order, and the very structure of their society, further east and centuries earlier. The Babylonians recognized the same celestial power, naming the planet Marduk after the patron deity of Babylon and the creator of the universe in their epic. The Enuma Elish Marduk was the hero god who defeated chaos and organized the stars into their proper places, and the planet Jupiter was his celestial throne. Babylonian astronomers were the first to track its 12-year cycle with mathematical precision, using its divine movements to develop the earliest systems of timekeeping and astrology. To them, Jupiter wasn't just a god. It was the cosmic clock that kept the universe running. Across the globe, from the Greeks' Zeus to the Norsemen's associations with Thor, Jupiter represented a stable, divine order. It was the king of the planets because its motion was perceived as perfect and purposeful. In the geocentric model of the universe, the belief that Earth sat motionless at the center of all things, Jupiter was thought to be a celestial body fixed upon a crystalline sphere, rotating around humanity by the will of a divine architect. For our ancestors, the heavens were a finished masterpiece, and Jupiter was one of its most brilliant, unchanging jewels. However, in the winter of 1610, this millennial divine order was suddenly and violently challenged by a simple piece of glass. In Padua, Italy, a lone mathematician named Galileo Galilei turned a handmade telescope, a tool originally designed for spotting ships at sea, toward the heavens. This was the first time human eyes had ever seen the king through an optical lens. And what Galileo saw shattered the ancient world. He didn't find a flawless, untouchable God or a perfect crystalline sphere. He found a physical world with a disk, a body of substance that hinted at a much larger and more complex reality. The most world-altering discovery occurred when Galileo looked closer at the bright light of Jupiter and noticed 4 tiny, pinprick points of light huddled nearby. At first, he thought they were distant background stars, but as he watched over subsequent nights, he realized they were following the planet, dancing back and forth in a perfect, rhythmic line. These were the Medicean stars, the moons we now know as Io Europa, Ganymede, and Callisto. By witnessing these satellites, Galileo provided the first visual proof that a celestial body could orbit something other than the Earth. This observation was the first major crack in the wall of ancient dogma. For nearly 2,000 years, the Aristotelian and Ptolemaic systems had insisted that Earth was the unique center of all motion in the universe. If Jupiter had its own moons, then Earth was not the only hub of the cosmos. It was merely one of many players. This was a direct threat to the religious and philosophical status quo of the 17th century. The idea that Earth and, by extension, humanity might not be the physical center of God's creation was a terrifying prospect that began to pull at the threads of the established world order. Galileo's discovery of the Jovian moons marked the true birth of modern science and the empirical method. It was the moment that observation took precedence over tradition and data outweighed the authority of ancient texts. Galileo didn't rely on what he was supposed to see. He relied on what he actually saw through his lens. This shift from philosophical speculation to observational evidence laid the foundation for the scientific revolution, encouraging a new generation of thinkers to question the nature of reality and to seek truth through measurement and experimentation. The biography of Jupiter thus underwent a radical transformation. It moved from being a symbol of the divine to a subject of physics. It was the first other world to be truly understood, a giant laboratory that allowed us to test the laws of gravity and motion. By looking at the king, we learned the rules of the entire solar system. The planet that once wielded thunderbolts was now revealing the mechanics of orbital resonance and the vast scale of the outer dark. The wandering star had become a destination for the human mind, a gateway to a much larger universe. Ultimately, the story of Jupiter's discovery is the story of human awakening. For thousands of years, we looked at the king and saw our own myths and shadows reflected in its light. But through Galileo's glass, we finally saw the king for what he was, a magnificent, terrifying and essential part of a vast cosmic clockwork. Jupiter remains a symbol of our transition from a species that creates gods to a species that explores worlds. The king still sits on his throne, but he is no longer a mystery to be feared. He is a giant to be understood. The first light that led us out of the darkness of dogma and into the clarity of the stars. For centuries, Jupiter remained a distant, flickering enigma, a masterpiece of pastel clouds that teased astronomers through layers of Earth's distorting atmosphere. We had mapped its movements and named its moons. But the planet itself was a fortress of radiation and gravity that many believed was impenetrable to human machinery. The dream of reaching the king required more than just powerful rockets. It required a leap of faith into a graveyard of asteroids and a moat of electromagnetic fury that had never been tested. In the early 1970s, that leap was finally taken, marking the beginning of humanity's transition from observers to explorers. In March 1972, a small, dish-shaped craft named Pioneer 10 embarked on a journey that many scientists feared would be its last. Its primary mission was to answer a terrifying question. Could a spacecraft survive the asteroid belt? At the time, researchers worried that the region between Mars and Jupiter was a dense thicket of pulverized rock that would shred any man-made object. Pioneer 10 became the first scout to brave this debris field, traveling for 7 months through a silent gallery of stones. When it emerged on the other side unscathed, the gateway to the outer solar system was officially declared open in December 1973. Pioneer 10 faced its final and most dangerous test, the Jovian radiation belts. As the probe dipped into the king's magnetosphere, it was bombarded by high-energy electrons and ions accelerated to near-light speeds. The radiation levels were 10,000 times stronger than those found around Earth. pushing the craft's primitive electronics to the brink of failure. For hours, the mission hung in the balance as instruments glitched and data hissed with static. Yet the hardened scout endured, proving that with the right shielding, we could survive a few brief passes through the King's Moat. The images sent back by Pioneer 10 were, by modern standards, blurry and pixelated, but in 1973, they were a global sensation. They were the first close-up photographs of the King's face, captured from just 81,000 miles away. They revealed the Great Red Spot as a towering, swirling vortex and showed the planet's atmosphere as a chaotic sea of storms. These images were more than just data. They were proof that the wandering star of the ancients was a tangible physical world. We had touched the edge of the empire. The success of Pioneer 10 paved the way for a much grander ambition. 5 years later, the mission shifted from simple survival to a profound discovery. In 1977, NASA launched the twin Voyager probes. Capitalizing on a rare planetary alignment that happens only once every 175 years. This grand tour was designed to use the gravity of the gas giants like a series of slingshots, flinging the probes from one world to the next. Voyager 1 and 2 were equipped with far more sophisticated cameras and sensors than the Pioneers. Designed to transform Jupiter from a distant planet into a cinematic reality, they were the eyes and ears of humanity, sent to document the King's court in unprecedented detail. When Voyager 1 arrived in March 1979, it delivered a series of shocks to the scientific community, the first of which was the discovery of Jupiter's rings. For centuries, Saturn was thought to be the only ringed planet in the solar system. But Voyager's cameras, looking back toward the sun, captured a faint, ghostly ribbon of dust encircling the King. These were not the brilliant ice rings of Saturn, but a dark, soot-like halo likely created by impacts on Jupiter's smallest, innermost moons. This discovery proved that the King had even more secrets hidden in the glare of his own brilliance. Perhaps the most jaw-dropping revelation of the Voyager missions occurred on the moon Io. Before Voyager, scientists expected the moons of the outer solar system to be geologically dead, cratered balls of ice. Instead, Voyager 1 captured images of massive umbrella-shaped plumes of volcanic ash rising hundreds of miles above Io's surface. It was the first time active volcanism had ever been seen on a world other than Earth. This discovery fundamentally changed our understanding of tidal heating, proving that gravity alone could melt the heart of a moon and turn it into a volcanic El-Cap. As Voyager 2 swept through the system a few months later, it turned its focus toward the frozen Cathedral of Europa. The images revealed a smooth white world crisscrossed by mysterious dark veins, looking more like a cracked eggshell than a solid moon. Voyager's data suggested that the lack of craters was due to the ice being young and geologically active. This provided the first real evidence for a subsurface ocean, igniting the modern search for life in the outer dark. Europa was no longer just a dot in a telescope. It was a potential habitat, a watery sanctuary in the shadow of the giant. Together, the Voyagers mapped the Galilean court with a precision that was previously unimaginable. They turned Ganymede and Callisto into complex, differentiated worlds with their own unique histories of impact and tectonic movement. They revealed that the Jovian system was not just a planet with satellites, but a mini-solar system in its own right, where the rules of physics were pushed to their extremes. The Voyagers didn't just take pictures. They wrote the first complete encyclopedia of the King's provinces. forever changing our perspective on the diversity of our cosmic neighborhood. The Voyager missions were the first time the public truly saw the solar system. The high-resolution color images of Jupiter's swirling bands and the Great Red Spot were published in magazines and newspapers across the globe, turning the Grand Tour into a cinematic event. We saw the motion of the clouds in time-lapse videos, watching as storms the size of Earth collided and merged. This was the moment the solar system became a real, vivid place for the average person, a destination that could be visited, even if only through the eyes of a robotic proxy. After their encounters with Jupiter, the Voyagers used the King's immense gravity to slingshot towards Saturn, Uranus, and Neptune. This gravitational assist allowed the probes to gain enough speed to eventually leave the solar system entirely. Jupiter had acted as the ultimate catapult, providing the energy needed for humanity to reach the very edge of the sun's influence. The King's role as the anchor of the system was now being used to launch our first steps into the interstellar void, a fitting use for the most massive world in our neighborhood. Today, more than 4 decades after their launch, the Voyager probes are the most distant man-made objects in existence. They have long since left the heliosphere, the bubble of charged particles created by our sun, and are now drifting through the true interstellar medium. They are the first emissaries of our species to enter the space between the stars. Despite their aging batteries and cold instruments, they occasionally still whisper back to Earth, sending faint signals that take nearly a day to reach our radio telescopes at the speed of light, carried on the side of each. Voyager probe is a golden record, a 12-inch gold-plated copper disc containing the sounds and images of Earth. It is a time capsule of our civilization, featuring greetings in 55 languages, the sound of a mother's kiss, the music of Batch and Chuck Berry, and 115 images of our world. This record was designed by a team led by Carl Sagan, intended as a message from Earth to any extraterrestrial civilization that might one day find the drifting scouts. It is a testament to our hope and our desire to be known in the vastness of the cosmos. The golden record is, in many ways, a message in a bottle cast into the cosmic ocean. The probes are not heading toward any specific star. They are simply drifting through the interstellar silence, where they will likely remain intact for billions of years. Long after our sun has expanded and consumed the Earth, and long after the human race has changed or vanished, these probes will still be out there. They are the most enduring monuments of our existence, carrying the heartbeat of 20th century humanity into the far future of the galaxy. The journey of the Voyagers into the interstellar silence is a poignant conclusion to their mission. They began as scouts sent to study a king, but they became the first pilgrims to leave the temple. Their silence is not a failure, but a final act of exploration. In the dark between the stars, they represent the ultimate reach of the human spirit, the drive to go further, to see more, and to leave a mark on the infinite. Jupiter was the gateway that allowed this journey to happen, providing the momentum for our first steps into the forever. The legacy of Pioneer and Voyager lives on in every modern mission to the outer solar system. They taught us how to navigate the radiation belts, how to use gravity as fuel, and how to interpret the bizarre chemistry of the gas giants. Missions like Galileo, Juno, and the upcoming Europa Clipper all stand on the shoulders of these early scouts. We no longer wonder if we can reach the king. We are now in the process of moving into his court, deploying more sophisticated tools to probe his depths and taste his hidden oceans. The transition from the blurry photos of Pioneer 10 to the high definition JunoCam images of today is a mirror of our own technological evolution. In 1973, we were just happy to survive the encounter. Today, we are analyzing the depth of the Great Red Spot and mapping the magnetic field with surgical precision. But we must never forget the raw excitement of those first Grand Tour images. They were the moments when the abstract math of the heavens became a tangible reality, and the wandering star became a place with volcanoes, rings, and ice as the voyagers drift away. The king remains behind, continuing his 4-billion-year vigil. He still swallows the comets that threatened the inner system, and his auroras still glow with the energy of his rotation. The probes we sent have documented his power, but they haven't diminished it. Jupiter remains a world of nightmare physics and forbidden forges. A giant that we have learned to respect through the eyes of our robotic proxies. The more we learn, the more we realize that the king is the essential character in our solar system's biography. The story of humanity's reach toward Jupiter is a story of expanding horizons. We moved from the naked eye observations of the ancients to the telescopes of Galileo, and finally, to the metallic scouts of the space age. Each step has revealed a larger, more complex universe than the one we imagined before. Jupiter was the first giant we mastered, and in doing so, we found the courage to look beyond the edge of our own system. The king was the catalyst for our growth as a spacefaring species. The first major milestone on our journey to the stars. Ultimately, the biography of Jupiter is also the biography of our own curiosity. We sent the pioneers and voyagers because we couldn't resist the urge to see what was hidden behind the bright light in the sky. As these probes drift forever into the interstellar silence, they carry with them the proof that we are a species that explores. We are a species that looks at a giant and sees not a god to be feared, but a world to be discovered. The king still sits on his throne, but thanks to his first scouts, he is no longer a stranger to us. In 1995, humanity's relationship with the king underwent a fundamental shift. We were no longer just passing by, catching fleeting glimpses during high-speed flybys. We had arrived to stay. The Galileo spacecraft became the first permanent resident of the Jovian system, orbiting the giant for 8 years. This mission transformed Jupiter from a destination into a laboratory. Galileo acted as a long-term observer, witnessing the changing weather patterns, the shifting volcanic plumes of Io, and the complex gravitational choreography of the moons. It was a mission of endurance that provided the first deep-time perspective on how a gas giant functions over the course of seasons. One of the most daring feats in the history of space, exploration occurred shortly after Galileo's arrival. The orbiter released a specialized atmospheric probe, a small, titanium-shielded capsule designed to commit a scientific suicide mission. On December 7, 1995, this probe plummeted into the Jovian clouds at 106,000 miles per hour. As it descended, it deployed a parachute to slow its fall, becoming the first human object to touch the atmosphere of a gas giant. For 58 minutes, it broadcasted a stream of data back to the orbiter, revealing a surprisingly dry and turbulent environment. Before the mounting heat and pressure finally vaporized the machine, today, our eyes on the king belong to Juno, a spacecraft designed specifically to face the planet's most lethal defenses. While previous missions like Voyager and Galileo stayed at a relatively safe distance to avoid the mode of electromagnetic fury, Juno was built like an armored tank. Its sensitive electronics are housed in a solid, titanium vault to withstand the relentless bombardment of high-energy particles. Every 53 days, Juno performs a daring perijove dive, screaming over the planet's poles and dipping into the danger zone, the gap between the atmosphere and the inner radiation belt. Captured data from just a few thousand miles away, the data returning from Juno has sent shockwaves through the scientific community, forcing us to rewrite every textbook on how planets are formed. One of the most staggering discoveries concerns the heart of the king. For decades, scientists believed Jupiter possessed a solid, rocky core about the size of Earth. Instead, Juno's gravity measurements revealed a fuzzy core, a massive, diluted region of heavy elements that is partially dissolved into the surrounding metallic hydrogen. This suggests that the early solar system was far more violent than we imagined, hinting at a primordial collision with a protoplanet that may have shattered the king's original heart. Juno has also looked deep beneath the visible cloud decks using microwave sensors, revealing that Jupiter isn't just a static ball of gas, but a complex, churning engine. We once thought the planet's weather was a shallow phenomenon limited to the top layers. Juno showed us that the famous colored bands extend nearly 1,900 miles, 3,000 kilometers deep. Even more surprising was the discovery of shallow lightning and mushballs, ammonia-rich hailstones, that act like a giant plumbing system, transporting nitrogen and water vertically through the atmosphere. This hidden weather cycle is what powers the planet's eternal storms. At the deepest levels of Juno's investigation lies the sea of liquid metallic hydrogen. By mapping the planet's magnetic field with surgical precision, Juno has shown us that this field is far more lumpy and irregular than we expected. This suggests that the electrical currents generating the field are moving in complex, shallow layers rather than a single deep mass. This discovery paints a picture of Jupiter as a planet-sized dynamo where liquid metal is squeezed and swirled by intense, eternal heat, creating a magnetic fortress that is constantly shifting and evolving. Among Juno's most bizarre findings is the Great Blue Spot, not a storm visible to the eye, but a concentrated patch of intense magnetic field near the equator. Unlike the Great Red Spot, which is a feature of the clouds, the blue spot is a feature of the planet's internal magnetic engine. Juno has tracked this spot as it drifts eastward, pulled by the deep atmospheric jet streams. This discovery provides a direct link between the visible winds we see on the surface and the invisible magnetic forces deep within the metallic sea, showing that every layer of the king is interconnected. When Juno first looked at the poles, it found a sight that defied all previous models. Instead of the single, massive vortices found on Saturn, Jupiter's poles are crowded with clusters of giant cyclones. At the North Pole, 8 storms circle a central vortex in a stable geometric pattern. At the South Pole, a similar pentagon of storms churns endlessly. These storms are the size of the United States and have remained in their positions for years. Juno's high-resolution images of these polar gems have revealed a level of atmospheric complexity that challenges our understanding of fluid dynamics on a planetary scale. Every dive Juno takes brings us closer to understanding the origin of our solar system, because Jupiter was the first planet to form. It holds the original recipe of the nebula that birthed the sun and the earth. By measuring the amount of water and oxygen in the deep atmosphere, Juno is helping us determine where in the solar system the king was actually born. Was it always in its current seat, or did it migrate from the outer dark? These answers are locked in the pressure-cooked chemistry of the Jovian interior, and Juno is the first key capable of unlocking them as Juno continues its mission. It prepares us for the next generation of explorers. The knowledge we gain from its nightmare physics is the foundation for the Europa Clipper and the JUICE mission, which will soon head to the Jovian court to search for life. We have moved from being curious onlookers to being sophisticated detectives, peeling back the layers of the king's shroud to see the engine beneath. Jupiter is no longer a god or a star. It is the ultimate masterpiece of planetary engineering. It's a world that Juno has shown to be more beautiful, complex, and essential than we ever dared to dream. As we transition into the 2030s, humanity's relationship with the Jovian system is undergoing a profound evolution. We are moving past the era of general reconnaissance and entering a period of targeted biological inquiry. The primary objective has shifted from mapping the atmospheric bands of a gas giant to investigating the potential for life in its surrounding provinces. We are no longer just looking at a planet. We're searching for a neighbor. This decade marks the beginning of a high-stakes investigation into whether the outer solar system's habitable zone extends much further than we ever dared to imagine. Currently, two of humanity's most sophisticated robotic emissaries are racing across the cold vacuum of the outer solar system, NASA's Europa Clipper and the European Space Agency's JUICE, Jupiter ICY Moons Explorer, represent the pinnacle of modern engineering. These missions are not redundant. They are complementary. Partners in a global effort to decode the mysteries of the Galilean court, while Clipper focuses its razor-sharp attention on the cracked ice of Europa. JUICE will conduct a broad survey of the system before eventually becoming the first spacecraft to orbit Ganymede, the largest moon in the solar system. The Europa Clipper is a mission designed with a singular, high-stakes focus to determine if Europa is habitable. It will not land, but will instead perform nearly 50 close flybys, skimming just 16 miles above the moon's surface. Its payload includes ice-penetrating radar, which will peer through the frozen shell to measure the depth of the ocean and the thickness of the ice. By tasting the plumes of water vapor that occasionally geyser into space, Clipper will search for salts, organic molecules, and the chemical signatures of a world that could support biology. While Clipper hunts for life on Europa, the JUICE mission will take a broader look at the King's Empire. It is designed to spend years orbiting Jupiter and performing flybys of Callisto and Ganymede. JUICE's primary goal is to understand these moons as planetary objects and potential habitats. By using a suite of remote sensing, geophysical, and InSight 2 instruments, the mission will map the hidden oceans of the outer court, searching for the internal heat sources and magnetic interactions that keep these distant worlds active and liquid. Search for life in the Jovian system is based on three fundamental requirements: liquid water, essential chemical elements, and an energy source. We already know the water is there, locked beneath the ice. The 2030s missions are tasked with finding the rest. They will search for carbon, nitrogen, phosphorus, and sulfur, the ingredients of life, and look for evidence of hydrothermal activity on the seafloors. If these ingredients are present, it means that the recipe for life is not unique to Earth, but is a universal phenomenon that can occur even in the dark. We are currently standing on the threshold of what could be the greatest discovery in human history. The confirmation of a second, independent origin of life within our own solar system would fundamentally reframe our place in the universe. It would suggest that life is not a rare accident, but a resilient and common feature of the cosmos. As the data from Clipper and Juice begins to trickle back to Earth in the 2030s, we may finally answer the ancient question, are we alone? This new era of exploration suggests that Jupiter may be more than just a vacuum cleaner or a wrecking ball. It may be the guardian of life. By providing the massive tidal energy required to keep these oceans liquid so far from the sun, Jupiter has created a sanctuary where life can potentially thrive in total darkness. The king doesn't just protect Earth by swallowing comets, fosters life in his own backyard by acting as a gravitational furnace, proving that a sun is not the only way to warm a world, looking much further into the future billions of years. From now, the story of Jupiter takes on an even more dramatic tone. Our sun is a middle-aged star that will eventually run out of fuel. As it ages, it will expand into a red giant, swelling in size and increasing its heat output. This will cause the habitable zone, the region where liquid water can exist on a planet's surface, to shift outward. The Earth, currently in the center of this zone, will eventually become too hot, its oceans boiling away as the sun's outer layers approach. In this final act of the solar system, the inner planets will face a fiery end. Mercury and Venus will be consumed, and Earth will be scorched into a barren, blackened cinder. The cradle of humanity will become uninhabitable, its atmosphere stripped away by the encroaching solar fires. But as the inner system burns, the outer system will begin to change. The frost line that once dictated the birth of the gas giants will retreat. The icy moons of Jupiter will experience a radical transformation as the sun's heat reaches the Jovian system. The miles-thick ice shells of Europa, Ganymede, and Callisto will begin to melt. Worlds that were once frozen cathedrals will become true ocean worlds, with liquid water finally reaching the surface. The dark oceans will be exposed to the light of a dying but brilliant sun, potentially allowing for the bloom of life that has been trapped in the dark for eons. The Jovian Empire, once a cold and lethal realm, may become the most hospitable place in the entire solar system in this far future scenario. The moons of Jupiter may become humanity's last best hope for a home, if our descendants are still around to witness the death of the sun. They will likely look to the Jovian system as a sanctuary. The moons provide the water, the gravity, and for a few 100 million years the warmth necessary to sustain a civilization. The outpost on the edge of the empire that we once imagined on Callisto could become the capital of a new human era, a maritime civilization living on the shores of melting ice worlds. Through all of this, the king itself will remain largely unchanged. Jupiter is too massive to be easily altered by the sun's expansion. It will continue to spin, its metallic hydrogen core continuing to generate its magnetic shield. In the twilight of the solar system, Jupiter will stand as the ultimate anchor, its gravity holding the remaining moons in place, even as the sun's grip begins to falter. The giant that saw the birth of the system will be the one to see its end, acting as the final sentinel in the dark. This perspective forces us to rethink our definition of home. We often view Earth as the permanent, unchanging center of our existence, but in the cosmic biography, Earth is just the beginning. The Jovian system represents the potential for a second act. By studying Jupiter and its moons today, we are not just doing science. We are scouting the terrain for the far future of our species. We are learning how to live in the shadow of a giant, preparing for a time when the inner light is no longer enough. The moons of Jupiter teach us that life is about resilience and adaptation. From the volcanic fire of Io to the hidden seas of Europa, the Jovian cord is a testament to the fact that energy and water can create complex environments in the most unlikely places. If life can exist there now, in the cold and the dark, we'll certainly thrive when the sun's warmth finally arrives. The neighbor we are searching for today may be the precursor to the neighbors we become billions of years from now as we wait for Clipper and Juice to arrive. The anticipation is palpable. We are like the ancestors who first looked through Galileo's glass, sensing that the world is about to get much larger. Every piece of data we gather is a step toward that greatest discovery, whether we find microbes, complex organisms, or just the potential for them. The result will be a turning point in the human story. We are the generation that will likely find out if the king is a lonely ruler or a crowded host. This mission into the 2030s is the culmination of thousands of years of curiosity. From the Babylonian priests who tracked Marduk to the modern engineers at NASA and ESA, we have always been drawn to the giant. We have moved from fear to wonder, and from wonder to investigation. Our drive to explore the Jovian system is the ultimate expression of the human spirit, the refusal to be confined by our own horizons, and the courage to seek life in the most challenging corners of the universe. Jupiter also serves as a bridge to our understanding of the wider galaxy. Most of the exoplanets we have discovered around other stars are gas giants like Jupiter, many of them with their own potential systems of moons. By mastering the physics of our own king, you're learning how to read the biographies of thousands of other kings across the Milky Way. Jupiter is the Rosetta Stone of planetary science. The key that allows us to translate the faint signals from distant stars into a coherent picture of how the universe builds worlds. Perhaps the king's final gift to humanity is this sense of perspective. Jupiter humbles us with its size, terrifies us with its radiation, but ultimately inspires us with its potential. It reminds us that the solar system is a dynamic, changing place, and that our story is inextricably linked to the giants that share our space. We are the children of the sun, but we are also the subjects of the king, living in a house that he helped build and continues to protect. As we look up at the bright, steady light of Jupiter tonight, we should see it not just as a planet, but as a promise. It is the guardian of our past, the sentinel of our present, and the potential harbor of our future. The king still sits on his throne, draped in his shroud of fury and wearing his crown of blue fire, waiting for us to arrive. The 2030s are just the beginning of our residency in his court. A decade where we will finally knock on the door of the frozen cathedrals and ask if anyone is home. This is the biography of the king, the story of Jupiter. From its birth in a cold graveyard of stars to its future as a blooming empire, it is the most essential character in our cosmic drama. It is the bully, the wrecking ball, the vacuum cleaner, and the guardian. It is a world of nightmare physics and hidden oceans, a giant that changed our history and may one day save our future. We live in the shadow of the giant, and in that shadow we have found the light of understanding.